This might be the best short circuit MIG video that I've ever done, but I'll let you be the judge in the comments. I'm going to show the best practice for beginners, which is padding beads, different wire feed speeds and settings which can affect travel speed, outside corner joints and settings, tips and techniques and settings for vertical uphill welding, as well as settings, tips, and techniques for overhead welding. Before we get into the meat of it, I want you to listen to these next 3 clips really closely, because you can tell a lot about a MIG arc, a short circuit MIG arc, by the way it sounds. The settings that are listed on a MIG chart on the inside of most MIG welders today are a good starting point, but that's it. I'm going to use the recommended settings here for 1/8 inch thick material, 18 volts, 236 inches a minute with 035 wire on this 11 gauge, roughly 1/8 inch thick steel. You can see the settings are not bad and sound a little bit like bacon frying. If I was after a certain look, I could turn the settings down just a little bit, or if I wanted to get done quicker, I could crank them up and it would still be okay. Let's look at some lap joints now, using that same thickness and those same chart settings. Once again, that's 18 volts and 236 inches a minute, using 035 wire, C25 gas. For the first half here, I'll do a pull angle. And since these are lap joints and there's nowhere for that upper leg to go, I'm just doing a kind of a straight drag, no real motion at all. And that makes for a fairly quick travel speed. Nothing wrong with this at all, just going in a straight line, no manipulation at all. Now some people like to push, so for those people we'll do a push angle. I don't really find that there's much difference. I've tested hundreds of these joints. There's minimal differences in the penetration, there's some differences in the spatter. But what you don't want to do is get real carried away with the angle. Someone's probably sprinting to the comments section right now to tell me that pushing's better or pulling's no good or whatever. When you start fabricating things and things are in the way, sometimes you have to push, sometimes you have to pull. When you're first learning to MIG weld, I think padding beads, stacking beads one on top of the other, is some of the best practice you can get. Those MIG chart settings work just fine for those 1/8 inch thick lap joints. But if you're padding beads, there's nowhere for the metal to bite or really go. You might want to trim the wire feed speed back a little bit. When you're learning and padding beads, it helps slow the whole process down a little bit, makes things go better. MIG machines all weld just a little bit different, but here are my settings I use for padding beads. This makes the bead kind of controllable, and when you're learning, things are happening really quickly and that wire is just pumping out of there. Plus, welding on a flat surface like this with nowhere for the metal to bite, that lower wire feed speed seems to make more sense. When you're doing this padding bead exercise, it's a good idea to push and pull, go left to right and right to left. It's time to learn, it's time to experiment. There's a lot of leeway when it comes to short circuit MIG settings. What you don't want to do is turn things too low just for the sake of appearance when it sacrifices a sound weld. Like I said, there's a lot of leeway on what will work on a certain joint and thickness type. This first T joint I'll weld at 212 inches a minute, 19 volts. I've got some hash marks on this one about every 1/4 of an inch, so you can kind of get an idea of the travel speed. It took me 10 seconds to travel 1 inch at this low setting. And that's neither good or bad. There are sometimes you might be in a position where a slow travel speed like this might kind of help you out. If you were welding 1/8 inch wall coped tubing, this might be a setting that you might use for that. But there's a lot of leeway. And if you had, say, 1,000 parts like this to do, this would just kill you on profit. You'd want to crank it up and go a lot faster. And that's what we're going to do now. Not terribly hot, but a good bit hotter. And use a slightly different technique, which will pretty much double the travel speed. So instead of it taking 10 seconds, an inch took only 5 seconds. It creates a whole different kind of a look. Not anything wrong with it. But it's not better or worse. It just goes to show you there's just a tremendous adjustment with the wire feed speed and voltage on the same thickness metal, the same joint, and they both will work. Let's do one with a push angle now. And the biggest difference I see in pushing and pulling, you tend to get a little bit more spatter when you push with the same settings And the bead does tend to lay down a little bit flatter on a T-joint like this, like there will be a lot less convexity in the bead. But that's getting in there pretty good. As I mentioned before, I have tested a whole bunch of these, pushing and pulling at all kinds of different settings, and the difference in penetration is very subtle. Let's talk about two things that make a really big difference that a lot of people don't pay much attention to when it comes to short circuit MIG. The first one is electrical stick out. That would be the distance from the contact tip to the arc. With short circuit MIG, you want to keep it really close, less than a half an inch. But the only way you can do that is if you have the tip flush or slightly protruding. Other thing is a good ground. This makes way more difference than people think. If you're having rough starts and it sounds like a drive-by shooting when you pull the trigger, make sure you got a good ground to clean bright metal or ground to the part itself. And here's a little hack that I found really helps a lot. You'll have a good ground here because you got so many little contact points. It's ugly, but it works. Outside corner joints require less heat than other fillet welds. To show that, I dropped the wire feed speed down all the way to 149 inches a minute for this outside corner joint. I don't normally weld with this low a wire feed speed on something like this, but I just wanted to show it can still get in there. I know it looks like it's kind of laying up there on the top, but it is kind of melting those corners off, and I'll show you the back side of it when this joint is done. You can push or pull. You can get good results either way, but you do want to limit extreme angles. This is cold rolled steel. If you were welding hot rolled, you definitely want to remove the mill scale. The MIG chart settings are almost always too hot to go vertical uphill. So what do you do then? Well, I have found that just selecting one or two thicknesses lower works fine. So let's weld some 1/8 inch thick material uphill. Instead of using the recommended settings, I'll drop down to 14 gauge and use 17 volts and 157 inches a minute. I'm going to hold a nice short stick out. I'm going to use this little upside down V technique that sweeps the arc across the leading edge of the puddle. And I'm going to pause just for almost no time at all on the toes of that weld. And that's going to progress me up and let me control the puddle while still getting some decent penetration. Sometimes I'll use this upside down V, other times I'll make a series of triangles, but either way I'm sweeping the arc across the leading edge. I'm tracing the leading edge of the puddle is what I'm doing. You could go downhill on this 1/8 inch material. I'm just showing the technique using 1/8 inch thick material. You've got to really be careful welding downhill with short circuit MIG. I think a 1/4 inch and above should be welded uphill anytime possible, especially when there's any mill scale, hot rolled mill scale involved. Now for this outside corner joint on 11 gauge, where it's all clean metal, not a bad application. Welding downhill with short circuit MIG is like falling off a log. It just kind of lays in there, and that's the problem. Sometimes it just lays in there with hardly any penetration. But for an outside corner joint like this with no mill scale and an open corner, it doesn't take much to get in there. I'm using that really low wire feed speed here again. You could just as easily use the recommended settings and just fly down this thing. But sometimes when you go hot like that, it actually is a detriment because it chases you. The puddle runs ahead of you and kind of blocks the arc from penetrating. So this kind of slows things down and still does a pretty decent job. Overhead with short circuit MIG is mostly a matter of getting comfortable and getting a good line of sight on the puddle where you can see exactly what's going on. I use almost the same settings that I would use for flat or horizontal. What you don't want to do is set a real weak arc, real puttering arc, just so you can make a pretty little caterpillar bead overhead. You don't want to do that. The real secrets are stick out and gun angle and making sure to have hot enough settings so that you got some punch to that arc. So let's use those recommended settings, 18 volts, 230 inches a minute. It's always a good idea to snip your wire to get a good crisp start. Same settings that I would use flat or horizontal on the bench. I'll usually use somewhere close to that for overhead welding. Sometimes I'll trim the wire feed speed back just a little bit, but it depends on if it's a T-joint or a lap joint. But for overhead, I will usually kind of work the puddle like this with kind of a series of cursive E's. I don't loop backwards into the puddle much, and you can slow the travel speed down and have more buildup by doing that, but I tend to just kind of make little loops, and that gives me kind of an even progression, and it kind of plays the light around, helps me see everything better Helps me see where I'm going, helps flatten out the bead, kind of helps prevent too much convexity. So using the recommended settings, which oftentimes are a little hot, worked just fine because I kept a short stick out and didn't get crazy with my angle. I'm going to let that cool off completely, and I'm going to lower the wire feed speed a little bit and see if we can't do better on the convexity, and then we'll do a little test on the end result. Wire feed speed is what controls amperage, but you do need enough voltage for an efficient burn. There's definitely a little subtle difference in this puddle, but what I'm really looking at is the very front leading edge, and as long as I take that arc and sweep it across that leading edge, I'm pretty confident it's going to penetrate into the root of the joint. But we're going to find out, because when we're finished with this weld and everything can cool off, we're going to do a little slice and dice, and we're going to check and we're going to compare the bead profiles. Nothing like a cut and etch test immediately after you make a weld, after it cools down, so you can correlate the puddle with the actual penetration. That looks almost just like the last one at a little bit higher wire feed speed, but you'll see here on the cross section there's main difference is the convexity. The one on the right is much flatter, that's with the lower wire feed speed, but there's no real distinct lack of fusion in either one of them. They both hit the root of the joint, they both got a little bit of depth of fusion. This is the welder I use for this video. It's a Prime Weld MIG 180, and I ran off a 115 volt, so it'll run off either 115 or 230. You can learn more at weldmonger.com. Let me know what you think in the comments, and please take us up on our free welding resources at weldmonger.com. The link will be in the description.